Hi class, this is lesson 4.3. It's factoring ax squared plus bx plus c when a equals 1. So this spot right here will always be 1, so really it'll just go away. So some vocab to remember: a monomial is an expression that is a number, a variable, or product of a number and one or more variables. So examples would be like 4, that's a monomial, x, 2x squared, and etc. So things like that. Those are examples of monomials. A binomial is the sum of two monomials. So examples of this would be like 4 plus x, or maybe negative x squared plus 2x. And then you could come up with a lot more, as long as there are two monomials that are separated by either an addition or a subtraction sign. A trinomial is the sum of three monomials. So an example would be 4x squared plus 2x plus 9. That would be one example of a trinomial. Another would be negative 3x squared minus 4x plus 7, because that has three terms as well, and we could come up with many more. And if you have more than three terms, we just call it a polynomial. So we know how to multiply two binomials using FOIL. You've done that for a while. Now we're going to reverse the process. So we're going to undo FOIL. And this is called factoring. And here's what I want you to remember. So I'm going to put a note right here. Oops, I accidentally pressed the wrong thing. I want you to remember. Just keep this in mind. Remember, ax squared plus bx plus c. Okay, this is what we're looking at. A here is 1, okay? So this 1 is just, or this a is just going to go away. It's just going to be x squared plus bx plus c. And here's what I want you to think. Okay? What multiplies to get c? That adds to up to b. So for all of these, I want you to identify your c and your b, and you have to think, what are the numbers that I can multiply together to get my c that add up to my b? So let's try some factoring here. Now this x squared is going to break down into x times x. 12. Our factors of 12 are 1 times 12, 2 times 6, 3 times 4. Those are our factors of 12. And we have to think, which of those pairs of numbers, my pen is writing really, really funny today for some reason. That's 3 times 4. And you've got to think, which of those numbers, when we add them up, give you positive 7? Well, it's 3 plus 4. So we know this factors into x plus 3 times x plus 4. So this next one, a good idea would be to pause it and try it. I'm going to do it in just a second here. Okay, this next one here, we're going to split it up into x times x. And then these last two numbers, 27, or the last one number, 27, I can think of 1 times 27, that gives me 27. 3 times 9 gives me 27. And notice here, I want you to notice that this is a negative 27. So one of these numbers has to be negative in order to multiply to give you a negative 27. So which pair, when you make one of them negative, are going to add up to negative 6? And it's going to be this pair right here, 3 and 9. And if I make 9 negative, positive 3 plus negative 9 gives you negative 6. So I need to make my 9 negative. So this factors into x plus 3 times x minus 9. And that's what it factors into. So next here, I'm going to move my screen down, or screen up actually a little bit. We're going to talk about special factors. So our special factors, the first one is the difference of two squares. So you've noticed here my general pattern is a squared minus b squared. So this works when your first number squared, and then you have a minus sign, and then you have a second number squared. And this always factors into a plus b times a minus b. So you must have only two terms. Each term must be a perfect square, and the sign in the middle must be subtract. So this is what you have to keep in mind. So looking at this first one, this is a perfect square, this is a perfect square, and we have a subtraction here. So the square root of c squared is c, the square root of 25 is 5. So this factors into c plus 5 times c minus 5. It's that quick. We don't have to do any work as soon as we recognize that it's the difference of two squares. So here's a perfect square, here's a perfect square, and we have a minus sign. The square root of x squared is just x. The square root of 121 is 11. So this factors into x plus 11 times x minus 11. The next one is perfect square trinomials. So let's do some problems with perfect square trinomials. And tri stands for 3, so these are going to have a letter squared first. Our last one's going to be a perfect square as well. And then in the middle, we're going to have 2 times a times b. And this is going to factor into a plus b squared. Or if you have minus sign, a minus here and a plus here, it's going to be a minus b, the quantity squared. So what we have to remember for this one is we must have 3 terms. The first and the last terms must be perfect squares. They must be perfect squares and positive. Okay, your middle term can be a negative, but the ones first and last have to both be positive. So looking here, I have a positive x squared, a positive 49 squared, and then this one's negative. So that tells me I'm going to be looking at this one right here. Okay, so I'm going to have a minus sign in the middle. Now the square root of 49 is 7. 2 times 7 is 14, so we know it works. So this is going to be x minus 7, the quantity squared. And you could go through and FOIL and do x minus 7 times x minus 7 and find out that you would get it simplified to x squared minus 14x plus 49. Right here, again, I have a perfect square, a perfect square. The square root of 144 is 12. 12 times 2 is 24. So I know this works out. Square root of this is 12. 12 times 2 is 24. So it works. I've got a plus sign here, so I know it fits this category. So it's going to be a plus b, the quantity squared. Now my b is the square root of this. So this factors into x plus 12, the quantity squared. All right, I need to turn my page quick here, so why don't you take a second to turn as well. Okay, so we've got a little bit more vocab here to talk about. A quadratic equation in one variable is ax squared plus bx plus c. I think when I updated this, it made it write a little different. So where a is not equal to 0. So in case that's kind of sloppy, it's ax squared plus bx plus c. That's what this should say right here, where a is not equal to 0. And this is called the standard form of the equation. Now, roots may be a new word for you. The roots of the equations are just the solutions of the quadratic equation. So if you hear me say the roots, that means find the solutions. The zero product property states this: if a times b equals 0, then a equals 0 or b equals 0. Okay? And we're going to find our a and our b by factoring. So here's our example right here. if I have the quantity x plus 3 times the quantity x minus 5, that equals 0, then I know that either one of those two has to equal 0. So I can say x plus 3 equals 0, or I can say x minus 5 equals 0. And then solving both, I can subtract 3 from both. So x equals negative 3, or I can add 5 to both of these ones. So x equals 5. So my two solutions to this equation, or my two roots, are x equals negative 3 or x equals 5. So those are my two solutions to the equation. So let's do some of these. The question here says find the roots or zeros of the following equations by factoring and use the zero product property. Now one thing I need to fix real quick here is this equals x squared. It needs to be over on the right side. Maybe I fixed it on your notes. Maybe I didn't. I'm hoping I remembered to do that. So this shouldn't be right here. So I'm going to cross it out. I moved it to the right spot. So notice this is it in standard form. We need to put it in factored form so that we can then split it up and find our two roots. So we're kind of putting everything together here. So we need to look, we need to look at this and think, what can I multiply to get negative 15 that adds up to negative 2? So negative 15, well, that's 1 times 15, or 3 times 5. And x breaks into x times x. So which one of those, 1 times 15 or 3 times 5, can I make one of them negative because it's negative 15, and then when I combine them, they add up to negative 2? Well, it's got to be this one right here, 3 times 5, and I've got to make my 5 negative. So I know this factors into x plus 3 times x minus 5 equals 0. Okay. Now I need to split those up. I need to use my zero product property to find the roots. So I can say x plus 3 equals 0, or x minus 5 equals 0. If I subtract 3 from both, I have x equals negative 3. 0 minus 3 is negative 3. Or, if I can add 5 to both of these, x equals positive 5. So my two solutions are right there, negative 3 and positive 5. Those are my two solutions, or other words, my two roots. Number 2 here. Now, it's not in standard form. Well, it is kind of, but there's no c here, so it looks a little different. And what I noticed right away is both of my terms have x's. So if you have just two terms, a binomial, and they both have the same factor in them. This one both has x. We need to take that x outside of parentheses and put what's left over in parentheses inside. And we did this in chapter 1. We did a little bit of this type of factoring. So you can do it. It's not too bad. So the first term, x squared, if I divide that by x, I'm left with just an x. And then minus 6x, if I divide it by left, I'm left with minus 6. So now I have it in factored form. I can split it up. I have x equals 0, or x minus 6 equals 0. If I add 6 to both sides here, I have x equals 6. So my two solutions are x equals 0 or x equals 6. There are my two solutions. Number 3, well, I've got things on both sides of this problem. So I definitely need to move things around a little bit. I need to have everything on the same side. So I want to move my 18x and my minus 81 to the other side in order to keep my x squared positive. So I'm going to do that by subtracting 18x from both sides, and then by adding 81 to both sides. So those two cancel. I'm left with 0 on the left equals x squared minus 18x plus 81. Now right away, I noticed that 81 right here, that's a perfect square. So you should start to recognize your perfect squared. Could you do this by factoring using the same way we did this? Yeah, it would work out, but it's quicker when you recognize that this is a perfect square. I recognize that that's a perfect square, and that's a plus sign. So this is 9. The square root of 81 is 9. 2 times 9 is 18. So this is going to factor into x minus 9 times x minus 9. So we can say 0 equals x minus 9 squared. So if I wrote that twice, x minus 9 equals 0 and x minus 9 equals 0, since it's the same thing, aren't I going to have the exact same solution? So I'm not going to worry about one of them. Just do one of these. So I'll add 9 to both. So x equals 9. And there is my solution. X equals 9. I'm trying to get my pen color changed so I can highlight that. X equals 9 is my solution. Okay, I'm going to move my screen up a little bit. Here we go. We are getting close to the end of this page right here. We got a little bit more vocabulary. Okay, so this right here is saying a 0 of a function is a value for x, which makes the function equal 0. The zeros of a function are the same as its x-intercepts. And you know what the x-intercepts are. You can remember that. The x-intercepts are where your graph crosses the x-axis. And we've done some graphing with x-intercepts. So zeros are the same as the x-intercepts on a graph. You can find the zeros by graphing or by factoring and writing the equation into intercept form. So let's find the zeros by rewriting the function into the x-intercept form and then check it by graphing. So really, actually, your zeros and your solutions and your roots are all the same thing, different ways of finding the same thing. But it's good to understand that when I'm saying find the zeros, you're finding the spot on the graph that are the x-intercepts. So we're still going to factor this. So let's factor number 1 here. Well, x squared we know is still x times x. 28. Well, we got 1 times 28. Or we've got 2 times 14. Or we've got 4 times 7. And it's negative 28, so I need to know one of those numbers have to be negative. So you've got to think, which of them can I make one of them negative, and then it'll add up to positive 3. Well, my pair's got to be 4 and 7. And if I make the 4 negative, negative 4 plus 7 is positive 3. So this is y equals x minus 4 times x plus 7. And now we want our roots, our x-intercepts, our zeros. And with our x-intercepts, think back to chapter 2, to find the x-intercepts, we let y equal 0. So instead of this y here, we're just going to put 0 in its spot. And now we can use the zero product property. So x minus 4 equals 0, or x plus 7 equals 0. So if I add 4 to both, that's supposed to be a 4. This writing's strange. So x equals 4, or if I subtract 7 from both, x equals negative 7. So there's my 2 solutions, and what that represents, if I graph this, so if I were to graph this one, I'm having a hard time drawing these in here. 1, 2, 3, 4, 5, 6, 7. Okay. If I were to graph these, my points, my x-intercepts would be at positive 4, which is right here, or negative 7, which is right here. And since my x squared is a positive number, I know my graph opens up. It should look something like this. Okay, and you could get a little bit more accurate graphs, but that's really what those roots tell us. So here are my two solutions, or my 2 roots, or my 2 zeros, and on the graph they would go right there. So let's do the second problem here. Remember, again, x squared can factor to x times x. 36, 36 is a perfect square. The square root of 36 is 6. Okay, so we know it's going to be 6, and let's just double check. Is 2 times 6 12? Yeah, it is. So this is going to factor into x minus 6, the quantity squared. So instead of y, I know to find my zeros, or my x-intercepts, I need to put 0 in for y. So I know that x minus 6 equals 0. I could say, or x minus 6 equals 0, but I'm going to get the exact same thing. If I add 6 to both of these, I know that x equals 6 is my one root. And what this would represent, if I were to graph this, 1, 2, 3, 4, 5, 6. Okay, so there's 6. And if I were to graph this, my x-intercept or my y-intercept would be right here at positive 6. And because my first term, my x squared, is positive, I know my graph would go up like this. So my graph would just touch the x-axis at one point, and that point would be x equals 6. 6 would be my root, or my solution, or my 0 of the function. So this is all for this lesson. Please make sure if you have any questions, you start, and we'll talk about it in class tomorrow. And have a fabulous night.